Hi everyone, Mr. King here. This is a trickier u-sub. This is a tough u-sub example, and I'm going to go over it with you guys so you get to see what you can do when they're even tougher than the ones that you've done for homework or that we've looked at in class so far. So this one is the integral from 0 to 4 of x divided by the square root of 1 plus 2x dx. The thing that's weird about this one, well, maybe not weird, but troubling, is that if we're going to do a u-sub here, it's not quite clear that the derivative of something that's in the integrand shows up somewhere else. Because the derivative of 1 plus 2x is 2, and that's not what x is in the numerator. And the derivative of x is 1, and that's not really there either exactly. It turns out, however, that this is solvable via u-sub. And the trick with this one is that we're going to let u be equal to 1 plus 2x, or 2x plus 1, which makes du equal to 2 dx. And it makes, not u, but makes x. Let's see, I'm working in a smart notebook, so I got to remember my controls are in a different place. There we go. So we're working with x here being equal to u minus 1 divided by 2. And this is what's different right here to do this. And you can see how I got x equals u minus 1 over 2 if we rearrange u equals 2x plus 1. This allows us to do the u-sub, it turns out. But to make it work, we need du. And we've only got, we need a 2 dx. And so we need to put a 2 in front of the dx, and we need to put a 1/2 in front of the integral to undo that multiplication by 2. So now we see that we do have du in the integral. And let's see what everything else looks like. So when we go to write this now, we have a 1/2 in the front, and the integral is not going to go from 0 to 4 anymore. It's going to go from u evaluated 0 and u evaluated at 4, and we'll figure out what those are shortly. Now x is u minus 1 over 2, so I'm going to write u minus 1 over 2 in the numerator, and we've got the square root of u in the denominator. And now this is with respect to u, so du goes there. This is the u-substitution that's going to allow us to evaluate this integral. And one thing that's very important to remember is that when we do a u-substitution, everything changes at one time. If it doesn't, then it's incorrect. And specifically, it's very important that the limits change at this stage of the game. If they don't, it is a mistake, and it's not clear to me that you would get full credit on a problem involving a definite integral and u-substitution on the AP exam, and I certainly wouldn't give you full credit because it would be a mistake not to change the limits at this point. So let's simplify this, and we're going to start to evaluate now. So u of 0 is 1, and u of 4 is 9. And what we're going to do next is we're going to manipulate the integrand, because it is manipulatable at this point, if I can use that word. And so it can be rewritten as this: u minus 1 divided by 2 times u to the 1/2 du. And then I'm going to go ahead and I'm going to bring this 2 out front. So that gives me a 1/4 out front. The integral from 1 to 9, u minus 1 over u to the 1/2 du, like so. And the next thing we're going to do is we're going to break the integrand. We're going to break that fraction into 2 pieces. And each piece is going to be simplifiable. So we'll get a u over u to the 1/2 minus 1 over u to the 1/2 du, like that. Don't want those lines, so let me get rid of those. And now I have to figure out how to move the screen. And this is a bit tricky. That's not exactly what I wanted to do. Okay, I've got my screen issue figured out now. And we're going to go ahead now and simplify, or I should say, yeah, I guess you could say simplify this integrand. U divided by u to the 1/2 is u to the 1/2, square root of u. And 1 over u to the 1/2 is u to the negative 1/2. And so this is what our integral is now looking like. This is quite doable. And at this point we can actually create one antiderivative that takes the antiderivative of each part of this combination that makes up our integrand. And so we'll go ahead and do it that way. So we've got a 1/4, and I'm going to need a bracket around this. And the antiderivative of u to the 1/2 is 2u to the 1/2. And the antiderivative of u to the negative 1/2, I'm sorry, I just made a mistake, didn't I? Let's back up. I was thinking of the second part of the antiderivative first. So for u to the 1/2, we need a u to the 3/2. And so I need a 2/3 in front of that. There's my antiderivative. And then for u to the negative 1/2, this is where I need the u to the 1/2, and I need the 2 in front of it to take care of the 1/2 when it comes down. And now our limits are 1 to 9. This is correct. And now what we've got is a 1/4 times 2/3, which is 2/12 or 1/6. And that's u to the 3/2. And I'm actually going to move this bracket. Oops, I guess it won't let me do that. Let me try that again. Move that bracket and put it right there. How's that for clever? And we'll multiply the result of evaluating u to the 3/2 at 9 and 1 in a moment. And then here I'm going to put the 2 out front, and then we've got the u to the 1/2, and we've got 9, and we've got 1. Now, depending on how comfortable you are with plugging numbers in and evaluating without actually writing it down, what I'm going to do next may be long-winded for you, too much detail. But I'm going to write it out so it's crystal clear. Nonetheless, if you can plug 9 in for u here and see that 9 to the 3/2 is 27, that's fine. But I'm going to write it out. Here we go. So 1/6, and the 9 goes in for u, so I have 9 to the 3/2 minus 1 to the 3/2. Of course, that will be 1, and then minus 2, and then here we've got 9 to the 1/2, that's square root of 9, minus 1 to the 1/2, which is 1, of course. And excellent, I'm figuring this out as we go. We've extended the page quickly. So we've got 1/6 times 9 to the 3/2. Well, 9 to the 3/2 is 9 to the 1/2 cubed. 9 to the 1/2 is 3, and 3 cubed is 27. 1 to any power is 1, minus 2 times the square root of 9, which is 3, square root of 1, which is 1. And so this simplifies to 1/6 times 26 minus 2. But I forgot something here, so let's back up a moment. Way back here, and so this is where you have to be careful with details in a problem with many steps. We have a 1/4 right here. That 1/4 multiplied the 2/3 to give us the 1/6. However, I forgot about that 1/4 when I wrote this 2. This 2 needs a 4 over it, so this is really a 1/2, this is a 1/2, and this is a 1/2. The reason I know this, and then this 3 minus 1 is a 2. The reason I know this is because I worked this problem ahead of time so that I would do it smoothly. Best laid plans, I guess. Now I'm having a little bit of trouble here with moving my screen. Okay, we got the screen back now. And let's see what we get. 1/6 of 26 is 26 over 6. Half of 2 is 1, which is 6 over 6. That gives us 20 over 6, which is 10/3. And that's our answer. I hope this tutorial helped. And again, I just demonstrated how you've got to be careful with your details. Thanks for listening. I hope that helped again. Over and out.